for standing by. Welcome to the Alcatel-Lucent International SIP Troubleshooting with Wireshark conference call. During the presentation, all participants will be in listen-only mode. Afterwards, we will conduct a question-and-answer session. If you have a question, press the 1 followed by the 4 on your telephone at any time during the presentation. At that time, your line will be briefly accessed from the conference to obtain information. If at any time during the conference you need to reach an operator, please press *0. As a reminder, this conference is being recorded Thursday, August 11, 2011. I would now like to turn the conference over to Tai-Chuck Choi, Alcatel-Lucent International. Please go ahead, sir.
Good morning, good afternoon, and good evening, everyone. I start the tutorial. Before beginning, I do not have a dedicated chat person monitoring the Q&A window, but if you have any question during the presentation, please do type it onto the Q&A window, and I will go over them at the end of the presentation during the Q&A session. So in this tutorial, I will go briefly over what is the Wireshark and when do you need to use it, and then talk about how to capture package, then look at the basics of the application itself, then go over the features that are related to specifically to voice over IP or SIP situation, including how to listen to the RTP stream, that is the voice itself. First, what is Wireshark? It is a network packet analyzer. Basically, it can capture network packet, and moreover, it can display the details of the package. And basically, instead of showing you this big binary data, it will show you the details of each packet. It is a open source software. It is released under GPL license, which means there is no restrictions whatsoever in the way you use it. And it is available for download on this website, www.wireshark.org. Wireshark.com is a completely different site, so you should use ORG. And it has been ported to a lot of platforms, including Windows. It supports both 32-bit and 64-bit Windows, Macintosh, Linux, Solaris, HP UX. If it is not available on the software on the server that you're currently using, then what you can do is you can typically use this command line tool called TCP dump, which has been ported to most of the Unix platforms, to capture the network data, save it to a file, move the file to your PC, and analyze the captured data with Wireshark that they can do. Wireshark used to be called Ethereal if you have been previously, then due to some trademark issues, the name changed. Currently, the latest stable release is 1.6.1, and I will be basing the presentation on that version. Earlier versions do not have much difference, only there can be some differences on the menu, the way that the menus have been placed. Some menu names and some items will be in a different place. So, when do we need to use the Wireshark? In voice over IP or SIP situation, it is mostly required when we need to look at the RTP data itself, like voice is only one way. You are hearing the customer voice by the agent, but the customer says, I cannot hear anything. The other is the quality issues, like there is a lot of noise, the voice sounds strange, or there are some droppings, or some voice recognition when there is voice recognition or DTMF recognition problems. Those RTP-related data is not typically recorded on any of the Genesis or non-Genesis log files. So if this kind of problems arise, you need to capture the RTP data using the Wireshark or other tool and look at it using Wireshark. Or there is other cases when it is needed, like when there is some need to look at the data on the network level, like you suspect that some package arriving late, or there is some lost packet that does not appear only one side of the log file, like it was sent from maybe SIP server, but DVP does not have any indication of receiving the message. Then you need to capture the package using Wireshark and look at it to determine whether it was indeed received or sent, and if it was lost, to find where it was lost. Finally, some components that Genesis or non-Genesis applications interact with may not have that much logging. For example, web servers typically have this one-line log, so it may not give you enough details. And voice gateways, although many times you can enable logging, but it could be quite hard. There is a limited resource for each gateway or even routers. So in that case, you need to use Wireshark to get the network level trace to find out actually what's going on. Then once you need determine that using Wireshark is required, the first thing that happens is capturing packet. If it is a very simple situation and like you are making some test calls, then you can just go ahead and click capture and start, and it will start capturing basically. But if it is in production environment and there is a lot of data going back and forth, you may need to use some additional options. And the two main options that I want to mention is the capture filter and the capture files. The first thing is capture filter. Basically, you can limit the packets that are captured. The capture field, so that if there are a lot of communication going on around, then you will not want to capture everything. It will be too much, and if you capture too much data, you will have some hard time analyzing it later. So there is some CPU issues, and if you are opening larger file, Wireshark may go slow. So some of the more used filters include the one that captures packets from to a host. You can also specify source and destination, but because most communications are bidirectional, you just need to, most cases, specify a host. In voice over IP situation, it would be most beneficial to specify a gateway as the host if there is only one gateway. If there are more gateways than one, then you can combine them with OR expression in between. Or also, you can limit the capturing to a particular port, TCP or UDP. So 5060 is a port that is typically used for SIP communication. But rather than limiting it to a port, more useful option would be limiting it to a range of because the RTP streams, the ports for the RTP streams, the ports are dynamically assigned, so it is not possible to determine in advance which port will be used. So, for example, with this kind of expression like UDP port range 5,000 to 50,000, you will be capturing most of the SIP communications and RTP streams as well, if there is any. And because UDP is not used that much by other applications, there won't be too much other noises or unnecessarily package that capture. Also, this condition be combined with AND or not. For example, if you just wanted to capture script messages between a particular host, then you can specify something like host IP address and port 5060. So once you find a capture filter that is useful, then you can save it and later reuse it quite easily. So once you click this capture filter button, there is a new window that has list of the saved captures. On here, you can give it the filter a name, then specify the capture string, and hit the new button. Then the capture filter will be saved and is available for later reuse. And the capture file, if you expect that there will be a lot of data that need to be or will be captured, then it is easier to it is beneficial to specify a capture file. You give it a name, and if you think there will be a large amount of data captured, then use the use multiple files options. Using this option, you can specify whether how large each file would be, or if you want to move to the next file at a defined time period, you can also do that as well. So there are two useful options: first the filter and specifying the file so that the captures are done in a more manageable size files. Here are something you before starting capturing some things that you need to consider. So the first thing is, nowadays, especially with servers, most networks use switches, no hosts anymore. So each host will not see, or each server will not see any other network package that are destined or is sent to any other host. So to overcome this issue, there are basically two ways. You can install Wireshark on the server host itself, like SIP server or GVP itself. Or if it is not allowed or not practical, you can use a feature of the most managed switches called port mirroring, which basically sends you the entire package of other network ports to one of the ports so that you can use Wireshark or any other network sniffer. On Cisco switch, this feature is called span. So you can ask the network administrator to enable the port mirroring or span feature if the Cisco switch is from Cisco. Second thing is, on Windows, the package that are sent between the servers that are running on the same machine cannot be captured. It is a limitation of the operating system itself. So if So there can be some manipulation of routing rules, so to send the packet out and come back, make it come back again, but it is not normally recommended. So unfortunately, if there is some communication, you suspect some communication problem between the components on Windows, and so it cannot be done. The thing is, even if you don't specify the capture file options in the capture options window, you can save the capture files later. So if the capture file is, you don't expect the capture file to be too large, you can just go on without specifying the capture file options and just save it afterwards that you determine if capturing is worth saving or need to send it to someone else. The final thing is, not the least important, it is quite important as well, that by default, by definition, the SIP and RTP follow different paths. It is mostly true with Genesis SIP server. It handles all the SIP messages between each SIP endpoint, including gateways, soft or hard phones, or in GVP and Stream Manager. But it does not handle any RTP stream. So if you want to capture SIP and RTP messages together, you have to choose port mirroring or the capturing point wisely. So if you just run Wireshark on the SIP server machine, then it is quite likely that you will not see any RTP stream on the capture file. So in most cases, the best places would be gateway ports, actually, or GVP if the main component you want to troubleshoot is actually GVP. So the next thing is, when you are using especially some servers are remote or on many Unix machines, you will not have GUI. In that case, you will have to use some command line tools. On Windows, the Wireshark comes with a command line application called T-Shark, which can be used to capture the package, and it can be later moved to the Windows, your local PC running Wireshark. So the command line would be tshark -I, then a number, or it can be a name as well, but Windows tends to use quite long names for its interfaces, so it is not practical to use names. So the command line would be tshark -I, then the interface number, and -F, and you specify the capture filter. And the final argument would be capture file itself with -W. Once you start capturing, to stop it, at some point you just hit Ctrl+C. And if there are multiple interfaces on the server, you can run tshark-d, and it will list the interface number and the name of the interface so that you can determine which one to use. On Unix machines, TCP dump has been ported to all the Unix variants as far as I know, or Solaris comes with a utility built by Sun or now Oracle called Snoop. With TCP dump, the command line is quite similar to T-Shark. Like it will be TCP dump -I and the name of the interface itself, then -W and the capture file. and -S and the capturing packet size. And the only difference is that you don't need a option for the capture filter. You just list the capture filter at the end of the TCP dump command line. With Snoop, the command line is slightly different. You can look at the manual page. But if you are using TCP dump or Snoop, the most important thing is you should remember to include this -S option, because some of the older version of TCP dump or Snoop is by default captures only the beginning of each packet. So it only captures the packets necessary for some network protocol builder. So it will just include the data about the TCP, maybe about the TCP protocol itself, and does not include anything after that, which is quite useless for us. So to remember to use -S and use 65535, the recommended value, or you can use any value larger than 10,000 or 15,000, because by Ethernet, even if you use jumbo frame, it cannot be larger than 9K. But when it is important that you use this -S and big value when you are using TCP dump. So you can use GUI or command line to capture the file. Then you can open the file in Wireshark to look at it. So this is how the main window looks like. It can be separated to 4 larger sections. The uppermost part is, of course, the menu and the buttons. Then comes the display filter, which allow you to limit the packets that are displayed. We'll talk about it in the next slide. Then there is the packet list. There is a given number in the capture files. It shows you time when the packet was seen, and the source and destination, etc. Then the third window is where the Wireshark really works. It shows you the details, and it actually gives a breakdown of packets into each area and and show you the packet in the detail, and gives each part what it basically tells you what each part means and each protocol specific data. The final area is raw data. It basically gives you hexadecimal representation and texture representation of the packet data, which can be sometimes useful, but we are more interested in the detail area in the most times. The first thing is about a few miscellaneous things. The first thing is the time displayed on the packet list. Wireshark basically has 2 ways of displaying time. The primary default way would be show you the number of seconds after the capture was started. And also, if you can change the way the time is displayed by going to the view and time display format to show you the time of the day. But the thing is, it uses the time when it captures, it uses the time of the PC or server or whatever computer that is capturing the package. So first you have to synchronize the time of the computer that is doing the capturing with any other server host so that you can compare the time with the log file if required. The second thing is when it is displaying the time determine the time of the day format, it uses the time zone of the PC that is running the Wireshark. So if the computer that is running the Wireshark capture is on GMT plus 9, and the PC that is you are looking at the time zone is on time GMT plus 10, and when you choose the time of day format, it will actually show you 1 hour difference. So if you are looking at a Wireshark capture that was done in another time zone, you can momentarily change the time of the time zone. You can temporarily change the time zone of your PC to match that of the capturing machine. Or you can also look at the beginning of the Genesis log file, find the time zone information, and use the same time zone to the Genesis log file to match the time zone so that you can see the same time of day Wireshark packet list. Next thing is, Wireshark basically uses the protocol information to determine what protocol is the package. But sometimes when you use non-standard package and there are a whole lot of non-standard package port numbers in DDT. So in that case, you can just right-click the package that Wireshark is decoding as a wrong protocol and select a menu called decode as. Then you can basically set Wireshark to decode a packet from a particular port, to a particular port to the protocol you want. There are 2 features that I want to mention about the main window. Then we need to talk about the display filters. The display filters have complete different semantic, different syntax as to the capture filter, and also you can use whole lot more conditions. In most cases, you can use most of the conditions, most of the attributes that happen inside it for a particular protocol to filter out the data stream, the list of packages that are displayed. And for example, you can see from this filter expressions window that you can see actual attributes of the state package itself, like method, request line, status, etc., to build the filter expression. And you can build this filter expression by just clicking this expressions button right beside where the filter expression is displayed. Another way of building this filter expression is you can build the filter expression from the package itself. So you find a package, either the beginning of a particular stream you want to look at, or one package that looks similar to the package you want to set the filter on. Then you find on the package detail window, you find the detail that you are interested in, or you want to build a filter on. Then right-click it and select this Prepare a Filter menu. What Wireshark will do is then it will put the filter expression, a display filter expression that will select this particular field or particular area of the packet into the display filter window. Then you can either use it as it is given or modify it to match the packet you want to be displayed and use it as a display filter, which is a quite fancy feature without need to looking through this filter window or the attributes you want to use. And when there is a lot of package on the capture file, you need to find it. To find it, you can use the menu called the find packages under edit, or you can type Ctrl F. And to find a field package, you can use a filter expression, or you can type a string or hex value, which can be used for SIP, because SIP is a plain text protocol. You can use string, or you can use a display filter to find a package that matches a particular condition. Then let's move on to some of the features that are specific to the voice of IP cores. So the way I found it is easiest is use the VoIP calls feature. Basically, under the telephony, you have a menu called VoIP calls, and when you select this menu, Wireshark will basically go over the entire capture file and find any voice over IP calls it can find and show you a list of the voice over IP calls in a separate window. And from this window, you can do three things: filter, flow, and player. So when Wireshark lists all the calls in that from the captured file, you select a call you are interested in. Then you hit the prepare filter button. Then what Wireshark will do is it will build a filter expression, display filter expression that shows you the packets that belong to only the packets that belong to this particular call into the display filter expressions area, so that you can examine the package in detail. The second thing is the flow button. It basically shows you a graphical representation of the VoIP call, so that you can quickly see what's going on. It will also show you the RTP streams, how many packages were there, and if there was any DTMF2 tones that was sent using RFC 2833 way, it will show it as well. And you can select any message on this graph, like I did for this try, and basically what Wireshark will do is it will display this particular package in the main window. So if you want to see the detail of any of the messages, you can just select it and go back to the main window and look at it and examine it in detail. The third feature is the player. It's basically Wireshark can play RTP stream when it is not encrypted, and also it has to be in G711, G711A or G711U format. Basically, you hit the player button, then it goes into the RTP player, and you click decode, and it will show you each RTP stream that is contained in that particular call. In this case, there were 2 RTP streams. And it shows you a graphical representation of the RTP streams to give you a rough idea whether there was much sound or not. Then you can select the streams that you want to play, then hit play button, and then you will be able to listen to that RTP stream using your computer's speaker or any other audio device attached to the computer. So in itself, Wireshark can only play G711 stream. If you need to listen to G729, you can do that as well with a help from the outside software. basically to listen to a G729 stream, you need to go to a different menu. It is basically telephony, RTP, and show all streams. Yeah, Wireshark, what Wireshark will do is it does not find calls. It basically finds all the RTP streams in the list of packets. It will show you as a list. Then you can use either the port and the IP address to find the RTP stream you want, or also you can use this SSRC, which is displayed in the graph representation. You can see the SSRC for the RTP stream on the graph. Then you find the RTP stream, select it, click Analyze, and then Wireshark will show you some details about the packet, jitter, and other things. But we are not interested in this at this time. So it will show you this. Then you can save the RTP stream payload as a file. And to listen to G729, you select the G729 stream, save payload, give it a name. The format would be raw, and the channels would be forward. After that, you can use this free G729 decoder, which has been created by this company called VoiceH. You can download it freely on their website. And you can run this decoder on the raw file that Wireshark saved. And this will decode that file into a 16-bit linear PCM format at 8K. So after this file can be imported into, for example, audio editors like Audacity, and then you can listen to the G729 stream. So it is a little bit convoluted compared to G711, but it is doable. G73 cannot be listened to. There is no freely available decoder. You can only, with free utilities, you can only listen to G711 and 729. But how can you match if you have a con ID from system log? How can you match that with all the packets in the Wireshark? There are two ways. One is you can use this call UUID that you can find as well in the system log. So this is a new attribute that was added in system, I think, 7.2. This is this long ID, and it tends to be more consistent than con ID. So you find it, and you can match. So basically, what system will do is, for all the step messages that this server sends, it will basically insert this call UUID in a custom header called x-genesis-call UUID. Like you can see it on these packet details. So you can build a display filter or search using tip.message HDR contains this particular call UUID. The only issue is that because it is a non-standard, it is not a standard tip header. Instead of specific headers, you have to use this filter expression that searches through all the headers. Well, because it's a very large value, you can typically match it. Or you can also find the zip core ID from the zip log itself, if you have seen zip log many times, and use the zip core ID to match a core on the zip log and the Wireshark trace. The only caveat, or the only thing you have to remember is that zip server tends to sometimes uses a lot of core IDs for a single core ID. In the case, it may be easier to find the code using code UID. The final useful feature is called follow stream. So in typical network, the typical network session is comprised of a lot of packets and a lot of streams. So following it through can be a challenge. So this is useful in not only in VoIP but in general network packet investigation. So you select a TCP or UDP packet, right-click it, and you can select this follow TCP stream or follow UDP stream menu. What Wireshark will do is basically it will only select the part of the package that comprise the stream on the filter and also show you a textual representation of the messages that came back and forth on that particular TCP socket session or UDP messages exchanges. So this is a handy feature. It comes quite handy when you are not investigating some problem that is using TCP. If you do need any further information, Wireshark guys maintain a wiki page. This is http://wiki.wireshark.org. But also, if you need some more information about the VoIP protocols that Genesis use, there is some simple guide, short guide on the SIP protocol itself at the end of the Genesis SIP server deployment guide. You can read through it. Or you can also read through the various RFCs that Internet Engineering Task Force published. They are all freely available, just like any other Internet related protocol. The RFC 3261 is the main RFC for session SIP protocol itself. And for SIP before method, you have to look at RFC 3515. So this is quite informational. And to understand the payload part of the SIP protocol, which is the SDP, Session Description Protocol, you have to look at RFC 4566. This tends to be, it is indeed a quite large RFC because the SDP has 4 or more capabilities than are used by typical VoIP applications. So you just need to skip through and only check the parts that are relevant to VoIP. In case you need to look at the RAP package in detail, you can look at RFC 3550 to understand what each part means. And also you can look at RFC 2833, which is the description of the method that is used to transmit ECMF information. That was the end of my presentation I prepared for Wireshark. Or you have also other resources you can look to Genesis for help. We have troubleshooting workshops for TWRS and servers, and also for outbound contact. You can also go to Genesis University. I know that now they have some SIP server installation, Genesis VoIP solution installation, and administration courses. Also, you can look at the general tech support knowledge base, which have product advisories, release notes, manuals, and white papers. Also, we have the solution search, where there are a lot of solutions, over 30,000 right now, you can use. And we also have these features to send you a notifications by email weekly or daily about our new product advisories and the release notes. Okay, the next tech tutorial will be about the interaction server. It will happen in 12th of October. can register for this and other sessions on the tech tutorial website. And if you want to comment on the tech tutorial itself, you can send emails to this email address, support.webadmin@nsxlet.com. Thank you for listening. And if you have any questions, operator, could you please open the question line for anyone who has the question?
Thank you. Ladies and gentlemen, if you would like to register a question, please press the 1 followed by the 4 on your telephone. You will hear a 3-tone prompt to acknowledge your request. If your question has been answered and you would like to withdraw your registration, please press the 1 followed by the 3. If you are using a speakerphone, please lift your handset before entering your request. Our first question will be 1 moment. As a reminder, to register for a question, please press the 1 followed by the 4 on your telephone. Once again, to register for a question, simply press the 1 and 4 on your telephone. Our first question comes from the line of Samid Tulay. The line is now open.
Hi. My question is purely from a security side. As if you allow people on Wireshark to access the RTP stream, is it possible for somebody to actually play back the audio? And if it is possible, I saw that in the presentation, is there any way we can disable that?
Yeah, from the Wireshark captures, any audio that is that is set in G711 or 729 can be played, and yes, it can be used in any way that the who have the file want to use. Did I answer your question?
Okay. And is there any way we can disable that?
Receive.
This is purely in a call center situation where people call in with a lot of PI information, and I think if you allow that, somebody could actually listen to a call and get the personal information, right? So is there any way we can disable that?
No, not actually.
So can that be disabled? So for example, but for capturing the package, you need to be physically installing this on the server, right? If it's not on, if a person has access to put something on the server, then they will be able to listen. If they don't have access to the server, they won't be able to listen. Is that a fair assumption?
Yes, it's right.
Okay. So that's fine. So only administrator can do that would be the answer, right?
Yeah, but so basically, as far as if you can install this application or get access to the network packet somehow, then there is no way to prevent them from personal information out of the captured packet. So you have to basically physically secure the environment to prevent those kind of things from happening.
Okay. Thank you.
Our next question comes from the line of John Tinsley. Your line is now open.
Thank you, and thank you for your presentation. Can Wireshark open more than one capture file at a time?
Yes, it can.
Oh, it certainly can. Okay, great. And a real quick question here. When will this be available as a replay?
I think it is next week.
All right. right, thank you.
There are no more questions from the phone lines at this time.
I don't see any other questions on the chat window as well. So if we don't have any other questions, then I think I will conclude this session. And thank you everyone for attending.
Ladies and gentlemen, that does conclude the conference call for today. We thank you for your participation and ask that you please disconnect your line.